Hey, welcome back. Today we're going to explore both the basic and advanced cleansing functions. Let's start with basic cleansing. Here you'll notice the Remove tab. This section gives you several options to remove unwanted strings and characters. Each option is designed for a specific use case. For example, let's say we want to clean up these 6 columns from our example 1 data source. One of the most common data quality issues is leading and trailing spaces. And with just a click, we can remove those. Now let's take a closer look at our phone numbers in the data preview sidebar. As you can see, they're not standardized. Some have spaces, others have punctuation, and that makes accurate matching much harder. Luckily, it's easy to fix. We can quickly remove spaces, punctuation, and even letters, so our phone numbers are clean and consistent, making them much easier to match with confidence. Additionally, if there's a prefix in front of the phone number, we can remove that too by defining it right here. Once everything looks good, just click Save and Add to include this rule in your task list. Now let's look at the Replace function. Before creating a new rule, let's first run a tokenization on the company column. This will show us the most frequently occurring values. As you can see, the ampersand appears 223 times in this column. Matching on an ampersand versus the word AND can reduce match confidence, so it's best to standardize it here. I'll define the ampersand as the source, or lookup text, and the word AND as the target or replacement text. In some cases, you might want the lookup text to be case sensitive, but that's not necessary here, so we'll leave that unchecked. Now let's save this rule to the rule list and move on. The Copy column option allows you to create a duplicate of any column. This can be helpful if you plan to make transformations for matching purposes, but still want to keep an untouched version for exporting or for tracking the changes you've made. It's a simple way to preserve your original data while working on cleansed or standardized versions side by side. Case options help you control how your data is displayed. You can choose between uppercase, lowercase, or proper case. Keep in mind, matching is case insensitive, so this won't affect match quality, just how your data looks. For example, in our Cities column, the text appears in reversed case. Let's fix that by adding a rule for the City column and selecting the proper case option. As you can see here, the result is clean, professional text in proper case. Next, let's check out the Fill Blanks function. This allows you to fill any empty cells with a static value of your choice. We can refer to our previously run profile and see that there are some empty email fields in our data. So I'll quickly add no email to fill those blanks, ensuring there are no empty fields left. That wraps up the basic features. Now let's move on to the advanced features. Let's start with the conditional function. This feature allows us to test values in a column and create one output if the condition is true, and another if it's false. For this example, I'll use my data source called myConditional, which is a list of contacts. Some are customers and others are suppliers. The account code column isn't standardized, but we can notice a pattern. Supplier codes contain SUP, and customer codes contain CUS, somewhere in the value. So for this first example, we'll select the account code column, choose the contains operator, and define our lookup value as SUP. This will check for SUP anywhere in the string. Next, for the output, we'll add a new column called contact type. If the test returns true, we'll fill that column with the static value supplier. If the test returns false, we'll fill it with customer. And here in the preview, you can see the result, the account code alongside our new contact type column, with values populated based on the conditional test. Let's look at one more example of using the conditional function. This time, we'll focus on the 2 phone number columns, main phone and home phone. We can see that both columns have some missing or incomplete data. Our goal is to create a new column with the most complete phone number possible. So we'll set up a conditional test on the main phone column and check if it's blank or null. We'll create a new column called phone final. If the test is true, we'll output the value from the home phone column. If the test is false, we'll use the main phone. And as you can see, the phone final column is now complete, showing either the main or home phone number based on the result of our conditional test. Now let's jump into the mathematical functions. Here you can easily add, subtract, multiply, divide, and average values across multiple columns. For this example, I'll use the MyNumbers data source. Starting with sum, we simply select multiple columns and define a new column to hold the result. For difference, we select two columns, first the minuend, then the subtrahend, and define the output column. The multiply option works just like the sum function. We select two or more columns, define an output column, and the product is calculated. With the divide function, we specify the dividend and the divisor, then set the output column. And finally, for the average, we select multiple columns, define the output column, and add the rule to the rule list. Next, let's look at the merge function. This allows us to merge data from two or more columns into a single new column. For these examples, I'll use the MyNames data source. I have a first name and last name column, and I'd like to combine them into a full name column. Let's start with a simple merge. I'll select the two columns, define a delimiter. In this case, I'll use a hyphen to make it more visible. Then name the new column and save the rule to the rule list. Now let's explore how coalesce works. Looking at MyNames again, we can see that both Phone 1 and Phone 2 columns are incomplete. Using the Merge Only Non-Blank Values option, I'll select All, which tells the system to merge only the fields that contain data. This prevents unnecessary delimiters from showing up in the result. Finally, let's try the first Not Empty option. I'll again select the phone number columns, but this time I'll set it to return only the first non-blank value. In this case, from Phone 1 or Phone 2. This is especially helpful when you have high-quality data that may be incomplete. You can prioritize your most reliable field first and use a secondary field as a backup to create a complete merged column. And here we can see the output of the three columns we created, each one containing the specific merged data based on the options we selected. Now let's take a look at the split function. This function allows you to define one or more characters to use as a delimiter for splitting values in a column. For this example, we'll use the email address column from our example 1 data source. The goal is to separate the username from the domain. We'll define the delimiter as the @ symbol and set a column prefix for the new fields. Since a split can result in multiple new columns, the system will use the prefix and add an incrementing number, starting with 1, to name the new columns. And here in the output, you can see the results. Email split 1 and email split 2, showing the user and domain parts of the email. Now let's check out the left-right function. This function allows you to extract a specific number of characters from either the beginning or the end of a string. In addition, you can use the exclude left and exclude right options to remove a number of characters from the start or end of a string. For this example, we'll use the My Company's data source. In the first column, we have zip codes, but they aren't standardized. To fix this, we'll extract the left 5 characters. I'll simply select the column, enter the number of characters, choose the left option, define the output column name, and save the rule. Next, let's work with phone numbers. Some include a leading +1, but we only want the core 10-digit number. So we'll select the phone column, set the character count to 10, choose the right option, and define our output column. For the next example, we'll look at the product number column. These values begin with 3 letters and a hyphen, a total of 4 characters. We'll use the exclude left option to remove those and keep only the remaining part of the string. Finally, let's look at the company contact type column. Here, every value ends with a trailing pattern like _A, B, and C. To remove this, we'll define 4 characters to remove from the end and use the exclude right option. Then we'll define the output column and save the rule. And here you can see the results of all 4 operations, each one showing clean, standardized output based on the rules we applied. Next, let's take a look at the search function. This feature allows you to search for a specific string within the values of a column. The result is a simple true or false, which is output to a new column that we'll define. For this example, I'll use the My Emails data source. We want to identify all email addresses that are Gmail accounts. To do that, we'll select the email column, enter Gmail as the search term, and define a new column for the output values. And here you can see the result. A new column showing true for Gmail addresses and false for everything else. Now let's look at the dynamic string function. This feature allows you to create custom strings by combining static text with column values. To start, let's build a JSON-style string for a contact name. We'll enter the static text, insert the relevant column headers where needed, and define a new column for the output. Next, we'll create a custom string that could be used for a form input or label, again combining static text with column values. And here, you can see the output of both examples. Dynamic, formatted strings built from your data. The last function we'll explore is the data conversion function. This allows you to change how your dates are formatted to fit different standards or system requirements. There are several format options to choose from. For this example, we'll select a database-style format that starts with the year, followed by the month, and then the day. This is especially useful when preparing data for imports into systems that require a standardized date format. Thanks for watching. We hope you found this video helpful. Until next time, Match Data Pro, an easier way to clean, match, and merge data.